In this video, we will learn the concept of the mole and molar masses and how to do conversion between mass, mole, and the number of units of a substance. So let us first go over the mole concept. The mole concepts were invented for the very same reason why we invented the dozen concept. We count eggs and donuts by the dozens, and the reason why is to help us speed up the counting. And similarly in chemistry, if we were to count atoms or chemical substances individually, that would become nearly impossible because they are very small. So instead, we count chemical substances, the amount of chemical substance, by the mole. And we see that a dozen of anything would then equal to 12 units. And here in chemistry, when we use the mole, 1 mole of something would then equal to 6.022 times 10 to the 23rd units. So it is very conceptually similar to dozen, except its value here is different. In this case, a mole equal to a very big value. And the reason why is again, because chemical substances are very tiny. If we were to have a sample of substances that we can see, there's a lot of units in there. So therefore, this value is then a big value. And this value is then also known as Avogadro constant, named after the chemist who came up with this concept. So this is called the Avogadro constant or number. And this is abbreviated with Na, stand for Avogadro constant. And this value right here would be defined in such a way that 12 grams of carbon-12 would then have exactly 6.022 times 10 to the 23rd of carbon-12 atom in it. So basically, there are 6.022 times 10 to the 23rd carbon-12 atoms in exactly 12 grams of pure carbon-12. So if we were to have carbon-12, a sample of pure carbon-12, and we weigh out 12 grams of it, then in this 12 grams right here, we will then find that there be 6.022 times 10 to the 23rd carbon-12 atoms in it. And therefore, we have the following per expression. 1 mole of carbon-12 would then equal to exactly 12 grams of carbon-12 if we were to weight it. And if we were to now count this, in here there will be 6.022 times 10 to the 23rd atoms of carbon-12 in it. So we have a relationship where 3 things are equal to each other. Therefore, we can set out any of this and make them equal to each other and write a fraction or a conversion factor for them. For an example, we can take out these two variables that are equal to each other and write the following. 1 mole of carbon-12 over 12 grams of carbon-12, or the reciprocal of it, or the reciprocal, which is 12 grams of carbon-12 over 1 mole of carbon-12. So that's one of the conversion factor that we can write for this relationship. We can also select out these 2 variables and write conversion factor for them as well. And again, because they equal to each other, therefore, if we were to take one divided by the other, we'll get 1. And thus we can write this following set of conversion factor. 12 grams of carbon-12 over 6.022 times 10 to the 23rd of carbon-12 atoms, or the reciprocal, where we have 6.022 times 10 to the 23rd carbon-12 atom over 12 grams of carbon-12, for an example. And similarly, we can also write the next one. We can take out this variable is equal to this variable, and here in this case right here, we will then have 1 mole of carbon-12 over 6.022 times 10 to the 23rd atoms of carbon-12. So that's an example of the 3 different types of conversion factor that we can write given this relationship above, where these 3 variables are equal to each other. And now let's go over the concept of a molar mass. What is the molar mass? As its name implies, the molar mass is the mass of a mole of substance. So the mass of 1 mole of a substance, that is then known as the molar mass. And so the mass in gram of 1 mole of a substance. Because now that we have 1 mole of a substance, and we know that 1 mole is a very, very big number. It has up to 6.002 times 10 to the 23rd units of a substance in it. Therefore, now it becomes very big, and thus it mass in the gram scale, which we can see. So therefore, when it comes down to the molar mass, the unit is then in gram. And to be more specific, its unit is in gram per mole. So we say x gram over to 1 mole of a substance. So how do we find the molar mass of a substance? Consider this following facts right here. The atomic mass of a carbon-12 is then equal to exactly 12U. And the molar mass of a carbon-12 is then equal to exactly 12 grams per mole. So in conclusion, we will then see that the molar mass of any substance is numerically equal to the atomic or the follow mass of that substance. The only thing that is changing now is that the unit is then changed to gram per mole rather than U. For an example, what would be the molar mass of CO2? So we have seen already that the formula mass of CO2 is then 44.01 U. So therefore its molar mass would now be 44.01 gram per mole. So that will be the molar mass of CO2. And for another example, what would be the molar mass of ammonium nitrate? And we have seen on the previous problem already that the formula mass of this is 88.04 U. So here in this case, it is asking for the molar mass. So the unit would now be gram per mole. So that's how we will find the molar mass of any chemical substances. We add all the masses of the different atoms together, and now its unit would then be gram per mole. And for any of this unit right here, molar mass, we can actually write them as a conversion factor as follows. For example, the molar mass of CO2 is 44.01 gram per mole. This means the following: 1 mole of CO2 is then equal to 44.01 gram of CO2. And therefore we can write this as a fraction. And similarly, for ammonium nitrate, we can also write the following: 1 mole of ammonium nitrate, and a mole sometimes abbreviated with MOL only, without the E, over 88.04 gram of ammonium nitrate. So that's the set of conversion factor that we can write. And of course, we can also write the reciprocal, where we have 88.04 gram of ammonium nitrate on the numerator. And on the denominator, we will then have 1 mole of ammonium nitrate. So that's how we'll be able to find the molar mass of any chemical substances. So please try the other example to make sure you know how to calculate molar masses, and I will be giving you the answer for you to check your work. And the answer are follow. For number 3, this would be 105.99 gram per mole. That would be the molar mass of sodium carbonate. And as for number 4, the answer would then be 46.07 gram per mole. And for number 5, 84.31 gram per mole. So these are the molar masses of these different substances. And now let's go over the conversion among mass, mole, and the number of units of a chemical substance. And so we have seen earlier already a very important relationship and related these three variables right here, and it is as follows again: 6.02 times 10 to the 23rd formula unit of a substance will be found in 1 mole of a substance. So we have 1 mole of a substance, we have 6.022 times 10 to the 23rd formula unit. We can use the word formula unit, or we can use the molecule for a molecular compound, and that will imply the same thing. Sometimes we use 6.022, sometimes we use 6.02, depending on how many suffix we want to carry over. And if we were to have 1 mole of a substance, that would have certain mass to it, in which now it equal to the molar mass. mm stands for the molar mass, and now the unit in gram of that substance. So again, we have these 3 variables right here that are equal to each other: formula unit or molecule of a substance is then equal to mole of a substance, and then equal to gram of a substance. Because these 3 relationships right here are equal to each other, therefore we should be able to convert among them very easily. If we want to convert between formula unit of a substance to mole of a substance, we will be using this relationship. And this relationship right here is then known as the, again, Avogadro constant. Or Na. And if we need to convert between mole of a substance to gram of a substance, then we'll be using this relationship, or this conversion factor. And this is the known as the molar mass, or 2m. And similarly, we can also convert between formula units of a substance to gram of a substance as well by using this relationship above. So in summary, we can do the following. If we were to start out with formula unit of a substance, we should be able to convert this into mole of a substance, of that substance, by using the Avogadro constant. And of course, we can go from formula unit to mole, or vice versa, from mole to back down to formula unit, depending on which unit is on the numerator and which one is on the denominator when we set up the Avogadro constant as the conversion factor. And similarly, we can convert, once we have mole of a substance already, we can then convert this into gram of a substance, or mass of a substance, by using the molar mass as the conversion factor. And similarly, this can be reciprocal. If we were to start from gram of a substance, we can go back to convert this back into mole, and from mole go back into formula unit. So that's how we will be able to convert among these 3 variables. And again, if we can also skip to go from gram to formula unit. We can skip the step in the middle and get over here directly by using the relationship between formula unit and molar mass of the substance. Let's now try a few practice problems. Number 1. How many carbon atoms are present in exactly 3 mole of carbon? So here in this case, our starting units will be 3 mole of carbon, and we're asking for carbon atom. So again, let's set this up by using dimensional analysis. And whenever we solve this kind of problem right here, we should always use dimensional analysis here in this class. So our starting unit is 3 mole of carbon. And please note that this 3 mole right here is exact as we've been told. And the wanted unit in this problem right here will then be carbon atoms. Now because carbon is an element, so in this case right here it is an element, and if unit here, the atom here, it basically its unit. So here in this case we can then see that we need to convert between mole to units. So between mole to unit. So we'll be using the Avogadro as the conversion factor. And now to set this up, starting with 3 mole of carbon, we see that for every 1 mole of carbon, there will then be 6.002 times 10 to the 23rd carbon atoms in it. So we'll be putting 1 mole of carbon on the denominator, so its unit can cancel out. And on top, we will then have 6.02 times 10 to the 23rd carbon atoms. And the unit mole of carbon cancel with mole of carbon. And now we end up with carbon atom, which then equal to 1.81 times 10 to the 24 carbon atoms. And the answer in this case right here will be rounded to 3 sigfig. As we use 6.022 times 10 to the 23rd, our answer will be rounded to 4 sigfig. But here in this case, the conversion factor is limiting the amount of sigfig that we have in the answer. Let's now try the next problem. How many atoms of gold are present in 5.0000 gram of gold? So if I would have a piece of gold weighing this much, how many carbon atoms are present in it? And if we think about the context of this problem, it would be a pretty cool problem, right? Because now it's allow us to figure out how many atoms that are present in a sample of something without even counting it. So here in this case again, the starting units would then be 5.0000 gram of gold. And we are asked, or the wanted unit would then be atoms, gold atoms. And if we were to now go back to our map that we have seen from above, we are starting from mass of gold. So in this case, we are starting out with mass of gold, which is this unit. And we are asking to figure out the atom of gold or the unit of gold, which is this unit in here. So there are 2 ways to go about this. We can go from gram into mole, and then from mole to units in here. So that will be the longer way. Or we can also go from gram into formula unit directly. So there will be a shorter way and a longer way. Thus, the more that we know how to use conversion factor, the faster we can solve problem. Instead of solving a problem in 2 steps, we can now solve this in 1 step. So in this example right here, let's go from gram. The most effective way to convert from gram of gold into atom of gold will be using this relationship from above. So let's do this. Here in this case, we start out with 5.00 gram of gold. And make sure you include all of these zeros, so that way we are not changing the sigfig in this problem. And now we will have to use the molar mass, right? So we have to have the molar mass of this gold. And the molar mass of gold is 196.97 gram. So 196.97 gram of gold will be found in, and in here there would be 6.022 times 10 to the 23rd gold atom. So that's how we would then set up this problem right here. In 1 mole of gold, which weight 196.97 gram of gold, there will be 6.022 times 10 to the 23rd gold atom in it. So in this case right here, that will be the one method way how to solve this problem. And this would then equal to 1.528 times 10 to the 22nd gold atoms. And 6.022 here, in this case right here, if we using this conversion factor, we have 4 sig fig to it. And our starting material have 5 sig fig in it. So in this case, we'll be rounding our answer to 4 sig fig because of the conversion factor. There's many other decimal places to this Avogadro constant as well. But here in most of the chemistry problem, we would be using 6.022 or 6.02, but we don't use any more sig fig compared to that. Let's now try the next problem. How much does 1.204 times 10 to the 24th gold atom would weigh? So if I were to take out this much gold atom, how much would it weigh? So let's solve this problem. And again, make sure we always think about using dimensional analysis. And in this case, we are starting out with gold atom. That is our starting unit. And in this case, we are asking for the mass gram of atom of gold. That is our wanted unit. So we have to convert from between atom into gram. So how will we do that? So here in this case right here, we are starting with, again, atom is a unit. So we started with unit, and we're asking to convert into gram over here. So we have to go from formula from units into gram. Now, because we have done a direct method, a direct conversion between units into gram already. So here in this example right here, I will set this up using the longer way by converting it into mole, and then from mole into gram. So that will be the longer way. It will not be the most effective way, but that will be a reasonable method of setting this up as well. So in this case right here, let's convert it into mole first, and then mole into gram by using the molar mass. So starting from 1.204 times 10 to the 24 gold atoms. And we then see that for every 1 mole of atom, there will be 6.022 times 10 to the 23rd gold atom in it. So therefore, we can write the following. 6.022 times 10 to the 23rd gold atoms, and then equal to 1 mole of gold. So that's how we get to the step here in the middle, mole of a substance. The substance here is the gold. And now for every 1 mole of gold, it will then weigh 196.97 gram of gold. So that's how we would set up this problem. And now we will then see the unit of mole of gold cancel out with mole of gold from here, and gold atom cancel with gold atom as well, and we'll end up with gram of gold. And in this case, this will then equal to 393.94 gram of gold. And now let's check to make sure that we have this rounded correctly. Here in this case right here, this value have 4 sig fig. This value right here have 4 sig fig as well. And this value have 5 sig fig. So we need to round our answer to 4 sig fig. So in this case, rounding to 4 sig fig. This will then equal to 393.9 gram of gold. And that will then be our final answer. And next, let's try this problem. Calculate the mass in gram of 1.75 mole of water. If I were to have 1.7 mole of water, how much would it weigh in terms of in gram? So in this case right here, again, our starting unit will then be 1.75 mole of water. And our wanted unit would then be gram of water. So in this case right here, once we have identified the starting and the wanted unit, we will then see that we need to convert between mole of water into gram of water. To convert from mole of water into gram of water, we have to use the molar mass, right? Because mole here and mass here. So to convert between mass to mole or mole to mass, we'll be using the molar mass of the substance. And the molar mass of water is 18.0 gram of water over 1 mole of water. So now let's set this up. 1.75 mole of water. And now we can see that 1 mole of water, which we'll put on the denominator so that can get cancelled out, is then equal to 18 gram of water. 18.00 gram of water. So in this case, this will then equal to 31.5 gram of water. And we have to round our answer to 3 sig. And that will be the final answer. And as for number 5, Mary drinks 500 milliliters of water. How many water molecules has she thus consumed? So let's figure this one out. So in this case right here, our starting unit is 500 milliliters of water. And now the wanted unit will then be molecule of water. Molecule is the units. So how will we solve this problem? So we have to convert between volume of a substance into molecule of a substance. And from above, the 3 variables that we have learned so far involve units, mole, and gram. But then volume is nowhere listed in here. However, we have learned from before already that if we were to start out with volume of a substance, we can convert that into gram of a substance by using its density as the conversion factor. So therefore, starting from the volume of water, we can convert that into gram of the water by using the density. And once we have gram of the substance already, to now convert this into molecule, we can use this conversion factor above. So that will be the solution map, how to solve this problem. So the solution map, it then equals, begin with volume of water. We can convert this into gram of water by using the density of water. And once we have density, the gram of water already, we now can convert this into the formula unit, a molecule of water. And how we will set this up is as follows. Starting from 500 milliliters of water. The density of water is 1.0 gram per milliliter. So we have to utilize that density right there to be able to convert from milliliter into gram of water. And now we can see 1 milliliter of water would weigh 1.00 gram of water. And now to convert between gram into molecule, we will then see that 18.00 gram of water will then have 6.022 times 10 to the 23rd water molecule in it. So now we see gram of water will cancel with gram of water, milliliter of water will cancel with milliliter of water, and we'll end up with an water molecule. So here in this example right here, the answer will then equal to 1.67 times 10 to the 25th water molecule. But now let's make sure that we have this rounded correctly. Here in this case right here, 500 milliliter here have only 1 sig. And that is the least amount of sig that we have here in this problem. So therefore we have to round this to 1 sig, which would then equal to 2 times 10 to the 25th water molecule. So do not forget the unit molecule in here. And that will then be our final answer. So in summary, conversion between units of a substance, whether the units a atom, molecule, or formula unit, into mole of a substance would be easy, and to be able to do that, we have to use the Avogadro constant as the conversion factor. And the Avogadro constant is basically 1 mole of a substance is then equal to 6.022 times 10 to the 23rd units of it. And once we get to mole of a substance already, we can convert this into gram by using the molar mass. Now again, molar mass convert mass to mole or mole to mass. So that will be a nice way for us to remember that. And again, molar mass convert mass to mole or mole to mass, depending on which unit that we put on the numerator and which one that we put on the denominator. We can convert mole to mass or mass into mole by utilizing the conversion factor.